Okay. Um, I'm following up on what I did at the end of class today. I wanted to go a little bit further, and I ran out of time. So I want to sort of go over what I did again, a little bit different version of the problem. And I'm going to give a problem that I wanted to give in class, but we ran out of time. So here's the problem I wanted to give. We have this Riemann sum, this infinite Riemann sum. And I want you to evaluate this by turning it into an integral. In other words, I want you to figure out what integral this is. And I'll come back to this. But that's the problem. That's what our goal is. I'm going to go back to a problem very similar to what we did in class today. And it's an easier version of the problem. So it's going to be the same function, y equals 2 plus x squared. And we're going to go from 1 to 3. So in other words, I'm looking at something related to this integral. That's kind of what I'm looking for. But I want to write that as a sum. So that's my goal. So in other words, I need to come up with something that looks like limit, sum, etc., etc., etc. So there's an art to how to do this. So the first thing we got to do is figure out what the function is. But there's a bunch of other stuff that we have to do too. So we know what the function is. You want to recognize the starting point, x0 and xn, a and b. That's given to us as 1 and 3 up here. Ck is equal to xk. And what that means is, like in class, it means that I'm drawing the rectangle, the height of the rectangle at the end of the rectangle. So that's where it crosses the graph. The height here is f of c1. The height here is f of c2. So there's some formula here. So I'm going to just go through these. So we know that x0 is going to be 1. We know that xn, which is the same as b, is going to be 3. So we have that. So we want to figure out what delta x is. Delta x is going to be the length of this interval, b minus a, 3 minus 1, over the number of rectangles. So again, what delta x is, delta x equals interval width over the number of rectangles. And that's just the difference of the endpoints over n, 2 over n. Now I'm just going to, this is this formula here. Now a is always the start. That's always where we start the integral. And so what I'm saying here is that our ck is going to be 1, because that's where we start, plus k times 2 over n. That's going to be my ck. And what I want to do is convince you of this, why this formula works. So that's the next step. So what I've done here, I've taken this, I've taken this interval down here and I've blown it up a little bit so we can focus in on it. I've laid out all the rectangles here. The rectangles will go up like this, etc., like that, except they'll be straight. And then what I want to do is I want to show you that we can find a formula for x, for these x's. And because of this, that'll give you our formula for C1. Now the key idea, and I think it's difficult if you haven't thought about it this way before, but once you get it, it's like, oh, that's what it is that basically, here's my delta x, and I can use that as a measuring stick. x1 is going to be 1 delta x away from C1. Well, how many delta x's does it take to get to x2? 2 of them. Now I'm at x2. How many to get to x3? 1, 2, 3. So really, we're using delta x as a measuring stick. We just need to count the number of delta x's. So to get to x1, 1 delta x, get to x2, 1, 2, get to x3, 1, 2, 3, and to get to k, like if k was 10, we count 10 delta x's. So let me start to write that out. So x1 is equal to my starting point plus delta x. Really, that's all I'm doing to get to there. Look at my formula for delta x, that's 2 over n. x2 is going to be my starting point, but then I have to move 2 delta x's over. And if I write out the formula, that's sort of be an equal sign, sorry, that's going to be 1 plus 2 times 2 over n. x3, same thing. Start at 1, I count 1, 2, 3, and I get 3 delta x's, and that's going to be 1 plus 3 delta x, 3 times 2n. So I keep going, And finally, when I get to, I'm sorry, I should mention this here, that's we're drawing the rectangles at these x values based on this. So that's it. Okay. So to get to ck, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. K, I move over k delta x's. So I 1 plus k delta x. My starting point 1. And this is where the 1 comes from. That's always going to be a. If you look at it right there. And then I just count over k delta x. I'm sorry, k times 2 over n. So that's my ck. That's where that formula comes from. So, oops. What I want to do is I want to continue this problem, but I want you to be able to see what we've done here. So hopefully you can see all that right there. Good. Okay, so what's going to continue down here? So we know that the integral 1 plus 3, 2 plus x squared is equal to the limit of f of ck delta x, okay? That's going to be, oops, I forgot the limit. Stick that in there. It's very important to put it in there, but you can abbreviate it like I just did. That's going to be 2 plus ck squared delta x. And now I just fill in things. That's going to be, look for my formula. I get lim, maximum delta x goes to 0. F of ck, which is going to be 2 plus, look for my formula for ck right here, 1 plus k times 2 over n, quantity squared, times delta x, which is 2 over n. So this is just that, and this is just this. So that's my Riemann sum for this. And if I want to see what this equals, well, I'm going to rewrite this one more way, just because I can't help myself. It's going to be 2 plus 1 plus 2k over n squared. That's the way it's usually written. And that's going to be equal to this thing right here. So if I asked you to evaluate this sum, well, you just integrate this. It's going to be 2x plus x cubed over 3. Evaluated at 3 and 1. That's going to be 6 plus 3 cubed, which is 27 over 3, minus 2 plus 1 cubed over 3. This is going to be 15. This is 2 1/3. That's going to be 12 2/3. So this sum is equal to this integral, which we can evaluate, and that gives us 12 2/3. So we're kind of cheating. Like I say, it's kind of a trick. So again, I want to just review things really quickly. XO is always A, XN is always B. If the delta X are uniform, that's your formula. This is always the formula for CK, where A is the starting point. That's always going to work for this kind of problem, as long as we have delta X uniform, CK equal, oh, I wrote that twice, CK equals XK, et cetera, et cetera. Okay, so I hope that makes sense.